I want you to imagine, just for a moment, that you are looking at a massive, incredibly detailed physical map of India.
Right. Not just a standard map.
Exactly. We aren't talking about a political map with, neat color-coded states and human-drawn borders.
Oh, yeah, those are totally different.
I want you to picture a map that shows the actual physical texture of the Earth. Like a map you could almost run your hands over and physically feel the ridges and valleys.
That's a great way to visualize it.
Because in the extreme north, you'd feel these stark, jagged, brilliant white ridges just cutting aggressively across the top.
Mm-hmm. The Himalayas?
Right. And then as your hand moves south, that frozen white suddenly gives way to this enormous flat swath of deep, rich green.
The plains.
Yeah. And if you keep moving south, the green starts to rise up again, turning into a massive, elevated triangular wedge, taking up the entire bottom half of the continent.
It really is a staggering visual when you step back and look at it as a single cohesive unit.
And that wedge is flanked by these long, golden coastal strips where the land finally drops off into the deep blue of the ocean.
Don't forget the desert in the northwest, too.
Oh, right, that sudden, stark patch of arid, textured yellow. It's wild.
Looking at one specific landmass that somehow manages to hold practically every major physical feature our planet is capable of producing.
All locked together in one giant geographic puzzle.
Exactly, yeah.
And that profound diversity brings us to the mission of today's deep dive. We are going to be exploring a foundational document that breaks down the physical features of this exact landscape.
Which is a pretty dense text, honestly.
It is, yeah. It's packed tight with vital geographical concepts, so we are taking a very specific approach for you today.
Right, the verbatim approach.
Yes. We are going to read it to you verbatim, block by block, exactly as it appears in the source.
So you don't miss a single detail.
Exactly. And the moment we finish reading a passage, we're going to unpack it. We'll translate it into clear language, explore the underlying mechanics of how these landscapes actually formed, and figure out what it means for the people who live there.
Which is a crucial exercise, because geography isn't just a static collection of rocks and dirt.
Right. It's not just background scenery.
No, not at all. Geography is the active stage upon which all of human life plays out.
Yeah.
The height of a mountain dictates exactly where the rain will fall. The composition of the soil dictates where a civilization can grow its food.
Which, I guess, dictates where the cities rise.
Precisely. Understanding the shape of the land is the absolute prerequisite to understanding the country itself.
Okay, well, let's begin decoding this landscape. The document starts by pulling our perspective all the way back to a planetary timescale.
Setting the stage.
Right. It draws this massive contrast between the ancient foundations of the Earth and the surprisingly new additions. I'll read the first part of this section.
Go for it.
It says, "You've already learned earlier that India is a vast country with varied land forms. What kind of terrain do you live in? If you live in the plains, you are familiar with the vast stretches of plain land."
A good question to ground the reader.
Yeah, it continues. "In contrast, if you live in hilly region, the rugged terrain with mountains and valleys are common features. In fact, our country has practically all major physical features of the Earth, i.e. mountains, plains, deserts, plateaus, and islands."
Which we just mapped out visually.
Exactly. Then it gets into the geology. It says, "The land of India displays great physical variation. Geologically, the peninsular plateau constitutes one of the ancient land masses on the Earth's surface. It was supposed to be one of the most stable land blocks."
Okay, that's a huge point.
It really is.
Yeah.
I'll finish the paragraph. "The Himalayas and the northern plains are the most recent landforms. From the viewpoint of geology, Himalayan mountains form an unstable zone."
Unstable, wow.
Right. "The whole mountain system of Himalaya represents a very youthful topography, with high peaks, deep valleys, and fast-flowing rivers. The northern plains are formed of alluvial deposits. The peninsular plateau is composed of igneous and metamorphic rocks with gently rising hills and wide valleys."
So there's a lot to unpack there.
There is. Okay, the most striking thing here to me is this massive distinction between the old and the new.
Yeah, the timescales are wild.
It describes the peninsular plateau in the south as an ancient landmass and a stable land block, but then it calls the Himalayas a recent landform and a useful topography.
That distinction is the key to unlocking literally everything that follows.
How so?
Well, when the text uses the word geologically, it's demanding that we stop thinking in terms of human lifespans. We have to think in terms of millions and billions of years. In geological time, the Himalayas are essentially toddlers. They are brand new.
Toddlers. I love that. But I'm trying to picture what a youthful topography actually looks like mechanically.
Yeah.
If I'm understanding the physics correctly, when mountains are young, they haven't been subjected to hundreds of millions of years of wind and ice scraping away at them, right?
Precisely. They haven't been sanded down yet.
Right.
Gravity and weather are the great equalizers of geology. Over immense periods of time, water and wind will wear any mountain down to a nub.
But the Himalayas are too new for that
Exactly. The weather hasn't had time to do its work. That is exactly why the text points out that they have high peaks, deep valleys, and fast-flowing rivers.
because the rock is still sharp.
Yeah. The slopes are impossibly steep because the rock is still jagged and fresh. And because the slopes are steep, the water flows incredibly fast, cutting those valleys even deeper.
Which creates an unstable zone.
Right. These mountains are still shifting, settling, and violently reacting to the forces beneath them.
Which is, I mean, the total opposite of the peninsular plateau in the south. The text says it has gently rising hills and wide valleys.
Like an old grandfather compared to the toddler.
That's a perfect analogy.
Mhm.
So that landmass has been sitting there for so long that the weather has basically sanded off all the rough edges.
Exactly. It is a highly stabilized environment. But the text also gives us a huge clue about how these regions formed by identifying the rock.
Oh, right. The alluvial deposits versus the igneous rocks.
Yeah, it says the northern plains are formed of alluvial deposits, while the plateau is composed of igneous and metamorphic rocks.
Let me try to deduce this for a second. Alluvial deposits. If we were talking about plains that sit right below those fast-flowing mountain rivers, alluvium must be the stuff those rivers are carrying, like dirt, sand, gravel.
You've got it. Alluvium is simply river dirt. The plains are just massive accumulations of sediment washed down from the mountains.
Okay, but contrast that with the plateau's igneous and metamorphic rocks.
Right. Entirely different origin story.
Igneous rocks are born of fire, right?
Yeah, they form when magma or lava cools and crystallizes.
And metamorphic rocks.
Those are rocks that have been fundamentally altered by unimaginable heat and pressure deep within the Earth's crust.
So to summarize the board, the southern part of the country is this ancient, stable, heat-baked, fire-born block of rock with smooth hills.
Yep.
And the northern part is this hyperactive, newly formed, jagged mountain range with a massive pile of river dirt just dumped in between them.
That completely sets the stage for the rest of the deep dive.
Awesome. And to organize our exploration, the document explicitly categorizes this board into distinct zones. I'll read the list.
Let's hear it.
Major physiographic divisions. The physical features of India can be grouped under the following physiographic divisions. 1. The Himalayan mountains. 2. The northern plains. 3. The peninsular plateau. 4. The Indian desert. 5. The coastal plains. The islands.
6 specific physical realities.
Right.
And just to clarify the vocabulary for you, physiographic simply refers to the physical geography, the structural shape of the Earth's surface in a given area.
Perfect. So let's start at the very top of that list, the most dramatic and, as we just established, the youngest feature.
The Himalayas.
Yes. Listen to how the text introduces the sheer scale of them. The Himalayan mountains. The Himalayas, geologically young and structurally fold mountains, stretch over the northern borders of India.
Fold mountains. That's a key term.
It goes on. These mountain ranges run in a west-east direction from the Indus to the Brahmaputra. The Himalayas represent the loftiest and one of the most rugged mountain barriers of the world.
Loftiest is almost an understatement.
I know. They form an arc, which covers a distance of about 2,400 kilometers. Their width varies from 400 kilometers in Kashmir to 150 kilometers in Arunachal Pradesh.
A massive arc.
Then it says, the altitudinal variations are greater in the eastern half than those in the western half. The Himalaya consists of 3 parallel ranges in its longitudinal extent.
Okay, let's pause and look at that phrase, structurally fold mountains.
Yeah, I want to ask about that. We know they're young, but what is the actual physical mechanism of a fold mountain? How does solid rock fold?
Well, it requires a shift in how we perceive solid rock.
Okay.
Under immense, slow pressure, rock can behave almost elastically. To visualize the mechanism, imagine laying a thick rug flat on a polished hardwood floor.
All right, I'm picturing a rug.
Now, place your hands on one edge of that rug and push it horizontally across the floor toward a solid wall.
Okay, so it slides until it hits the wall.
Right. And as the rug hits the wall, it can't go forward and it can't push down into the floor. So what happens?
The material has no choice but to buckle and bunch upward. it folds into ridges.
Exactly. So instead of a rug, we're talking about a tectonic plate.
A massive slab of the Earth's crust.
Right, sliding across the planet and crashing into another plate, and the crust literally crumpled upward.
That is insane to think about. The landmass of India pushed northward into the Eurasian plate, and the resulting crumple zone created the Himalayas.
And the sheer scale of this geological crumple zone is just difficult to fathom.
The text notes it forms an arc covering 2,400 kilometers.
Right. Let's put that in human terms.
Yeah, if you were driving on a highway at 100 kilometers an hour, you would be driving for an entire day and night, 24 hours straight, just to trace the length of this mountain range.
And it's incredibly thick, too.
Yeah, 400 kilometers wide in the west, tapering down to 150 kilometers in the east.
Notice also the detail about the altitudinal variations being greater in the eastern half.
What does that actually mean on the ground?
It means the shifts in elevation, the sheer drops from the peaks to the valleys, are much more abrupt and extreme in the east than in the west.
Oh, wow.
But structurally, the most important takeaway is the final sentence of that section.
The Himalaya consists of 3 parallel ranges in its longitudinal extent.
Yes, it's not just one wall of rock.
So if you are standing on the plains and you start walking straight north, you are going to encounter 3 distinct sequential walls.
Exactly.
Let's look at the very first one, the highest and most formidable barrier. Here's the verbatim text. A number of valleys lie between these ranges. The northernmost range is known as the Great or Inner Himalayas, or the Himadri. It is the most continuous range, consisting of the loftiest peaks with an average height of 6,000 meters. It contains all prominent Himalayan peaks.
And then it gives a table of those peaks.
Right. It lists Mount Everest in Nepal at 848 meters, Kanchenjunga in India at 8598, Makalu at 8481, Dholagiri at 8172, Nanga Parbat at 8126.
It's a staggering list.
Annapurna at 8078, Nanda Devi at 7817, Comet at 7756, Namcha Barwa at 7756, and Gurla Manhata at 7728.
All just astronomically high.
And the text finishes this part by saying, the folds of the Great Himalayas are asymmetrical in nature. The core of this part of Himalayas is composed of granite. It is perennially snowbound, and a number of glaciers descend from this range.
Let's talk about that average height of 6,000 meters.
Yeah, that number is just sitting there in the text, but we need to translate what that actually means for a human being.
It is a profoundly hostile environment. 6,000 meters is roughly 20,000 feet.
That's commercial airplane cruising altitude territory.
Almost, yeah. At that altitude, the atmospheric pressure is less than half of what it is at sea level. The human body struggles simply to oxygenate its blood. And remember, that is just the average height.
Right, Everest is almost 9,000 meters.
Exactly. You are looking at rock formations that are literally piercing the lower boundaries of the stratosphere. These peaks exist in the death zone.
The death zone. That's terrifying.
It's an altitude where there isn't enough oxygen in the air to sustain human life for more than a brief period.
And the physical composition of this towering wall tells us a lot about the violence of its creation. The text says the folds are asymmetrical, and the core is composed of granite.
Let's break that down. Asymmetrical implies that the tectonic pushing wasn't perfectly neat or uniform.
Right, the rug didn't fold perfectly.
Exactly. If you slice a mountain in half, you won't see a perfect pyramid. One side might be a long, gradual slope, while the other side is a terrifying, sheer vertical cliff face.
The rock buckled unevenly.
Yes. And the presence of a granite core is a massive clue about how deep this crumple zone goes.
Because granite forms deep underground, right?
Very deep. It's an igneous rock that forms from slowly cooling magma deep within the crust.
So, for granite to be sitting at the core of peaks that are 8,000 meters in the sky,
the tectonic collision had to be so violent that it literally scooped up the deep foundational crust of the Earth and shoved it into the atmosphere.
that is mind-blowing. And because it's shoved so high up, the text notes it is perennially snowbound. Perennial meaning permanent.
It never melts.
Never.
Never. The ambient temperature at that altitude is permanently below freezing, regardless of the season or the sweltering heat on the plains below.
So the moisture in the air is locked in a frozen state.
Right, which is why a number of glaciers descend from this range. These aren't just snowy hilltops.
The rivers of ice.
Massive reservoirs of ancient, highly compressed ice. They act like giant, slow-moving bulldozers, constantly grinding against that granite core, slowly carving out the valleys.
Man. So that is the Great Himalayas, the innermost towering wall of frozen granite. Now let's step south to the middle wall.
The Himachal.
Let's listen to how the environment changes. The text says, The range lying to the south of the Himadri forms the most rugged mountain system and is known as Himachal, or Lesser Himalaya.
Rugged is the key word there.
The ranges are mainly composed of highly compressed and altered rocks. The altitude varies between 3,700 and 4,500 meters, and the average width is of 50 kilometers.
So we've dropped down a bit.
Yeah. While the Pirpanal Range forms the longest and the most important range, the Daladar and the Mahabharat ranges are also prominent ones.
Right.
This range consists of the famous Valley of Kashmir, the Kangra and Kulu Valley in Himachal Pradesh. This region is well known for its hill stations.
Okay, so from an average of 6,000 meters in the Himadri, we are now looking at altitudes between 3,700 and 4,500 meters.
It is a significant drop, but I mean, this is still incredibly high altitude.
Oh, absolutely. However, the geology has completely shifted. The text points out these ranges are composed of highly compressed and altered rocks.
Which links back to the metamorphic rocks mentioned in the opening overview. Right?
Exactly.
Because if something is compressed and altered, it's been subjected to massive heat and pressure.
You've got it. This middle section, the Himachal, essentially acted as the primary shock absorber during the tectonic collision.
Oh, wow.
The rocks here didn't just fold, they were squashed, shattered, heated, and chemically transformed by the immense friction and weight.
That is why the text describes it as the most rugged mountain system. It is a chaotic, broken, highly irregular landscape.
Yes. But intriguingly, this rugged, broken landscape is where the text highlights major human interaction.
Yeah, it mentions famous valleys like Kashmir, Kangra, and Kulu, and knows it is well known for its hill stations.
Right.
But why build settlements here in this fractured rock rather than further south?
Well, because the Himachal Range represents a geographic Goldilocks zone.
Not too hot, not too cold.
Exactly. The Himadri to the north is an uninhabitable frozen wasteland. The plains to the south can reach punishingly high temperatures during the summer. But at an altitude of 3,700 to 4,500 meters, the climate is crisp, cool, and temperate. Historically, colonial administrators built hill stations here precisely to escape the heat of the plains.
That makes perfect sense.
Furthermore, because this range is so rugged and broken, it features deep, wide valleys trapped between the peaks.
And those valleys are habitable.
Highly habitable. They are relatively flat, incredibly scenic, and highly fertile, making them perfect enclaves for human habitation within an otherwise extreme environment.
Amazing. So we have the inner wall of frozen peaks and the middle wall of rugged habitable valleys.
Which brings us to the final, outermost wall.
Right. Listen closely to what this final wall is made of. The outermost range of the Himalayas is called the Shiwaliks. They extend over a width of 1050 kilometers and have an altitude varying between 900 and 1100 meters.
Much lower now.
These ranges are composed of unconsolidated sediments brought down by rivers from the main Himalayan ranges located farther north.
That is a crucial sentence.
These valleys are covered with thick gravel and alluvium. The longitudinal valley lying between Lesser Himalaya and the Shiwaliks are known as duns. Dehra Dun, Kotli Dun, and Patli Dun are some of the well-known duns.
Right.
And it continues, besides the longitudinal divisions, the Himalayas have been divided on the basis of regions from west to east. These divisions have been demarcated by river valleys.
Cutting the mountains into sections.
For example, the part of Himalayas lying between Indus and Satluj has been traditionally known as Punjab Himalaya, but it's also known regionally as Kashmir and Himachal Himalaya from west to east, respectively.
Okay.
The part of the Himalayas lying between Satluj and Kali rivers is known as Kuman Himalayas. The Kali and Teesta rivers demarcate the Nepal Himalayas, and the part lying between Teesta and Dihang rivers is known as Assam Himalayas. There are regional names also in these broad categories.
Let's go back to that fascinating mechanical shift at the start of that section.
Yeah, the text says the Shiwaliks are composed of unconsolidated sediments brought down by rivers.
Right.
So this outer mountain range isn't made of pushed-up bedrock like granite or metamorphic rock.
No, it isn't. And the creation of the Shiwaliks is just an incredible testament to the power of water over deep time.
Because unconsolidated simply means loose, right?
Yeah.
Not fused together into solid stone.
Exactly. We are talking about loose sand, gravel, and dirt.
So how does a pile of loose gravel become a mountain range reaching 1,100 meters high?
Think about the glaciers melting high up in the Himadri.
Okay, the water starts flowing down.
They form powerful rivers that rush down the steep slopes, cutting aggressively through the rugged Himachal range.
And fast water carries a lot of energy.
Immense kinetic energy. That allows it to transport billions of tons of eroded rock, silt, and gravel. But As these rivers finally reach the edge of the flat plains, they suddenly lose their steep gradient.
They slow down.
Right, and as they lose velocity, they lose energy, and they just drop all that heavy rock and gravel.
Oh, wow.
Over millions of years, an unimaginable amount of debris piled up at the foot of the mountains.
And then what?
Well, the tectonic plate continued its relentless push northward. So even this massive pile of loose river debris was squeezed and pushed upward, folding into a new, lower range of hills, the Schuwaliks.
That is incredible. They are mountains made from the recycled ruins of the mountains above them.
Yes.
And because of how they formed, they create a unique geographical trap. The text mentions duns, like Dun, longitudinal valleys lying between the Lesser Himalaya and the Schuwaliks.
Right.
So if you are standing in a dun, you have the hard, rugged rock of the Himachal to your north and the pushed-up river gravel of the Schuwaliks to your south. You are literally in a valley caught between two distinct ages of geology.
A perfect summary. And then the text transitions from looking at the mountains structurally from north to south to mapping them regionally from west to east.
And it uses a very specific tool to draw these borders, river valleys.
It slices the 2,400-kilometer arc into chunks.
Right, the Indus and Satluj rivers bracket the Punjab Himalayas, the Satluj and Kali bracket the Kuman Himalayas, and so on. It's almost like using a knife to cut a massive loaf of bread, where the rivers are the cuts separating the regions.
It demonstrates how deeply rivers define the landscape. They aren't just features on the map. They are the actual boundaries that divide entirely different ecological and cultural zones.
So true. And speaking of dividing lines, the text takes us to the absolute eastern edge of this massive mountain system, and things change drastically.
Let's hear the final paragraph on the mountains.
The Brahmaputra marks the easternmost boundary of the Himalayas. Beyond the Dihang Gorge, the Himalayas bend sharply to the south and spread along the eastern boundary of India.
Bending sharply south.
They are known as the Purvachal, or the Eastern Hills and Mountains. These hills running through the northeastern states are mostly composed of strong sandstones, which are sedimentary rocks.
Another big shift in the geology.
Covered with dense forests, they mostly run as parallel ranges and valleys. The Purvachal comprises the Patkai Hills, the Naga Hills, the Manipur Hills, and the Mizo Hills.
Okay, two huge changes jump out here for us to analyze.
First, the mountains hit the Brahmaputra River and bend sharply to the south.
Right.
Second, the rock composition completely changes again. We went from granite to compressed metamorphic rock to loose gravel, and now the text says these eastern hills are composed of strong sandstones, which are sedimentary rocks.
Yeah.
Why the sudden shift to sandstone?
Well, this tells us a slightly different tectonic story. Sandstone, as the text notes, is a sedimentary rock.
Meaning it's made of sediment.
Exactly. This means it wasn't born from magma or transformed by deep earth pressure. It was formed by sediment, specifically sand accumulating layer upon layer, often at the bottom of ancient seas or massive river deltas.
And it's slowly cemented together over millions of years.
Right. So when the tectonic collision reached this eastern edge, instead of pushing up deep crustal granite, the folding process pushed up these ancient cemented layers of seafloor and beach sand.
Ah, I see. And because it's sandstone, and because it sits so much further south along the eastern boundary, the climate is entirely different.
Completely different.
We aren't dealing with frozen peaks anymore. The text says they are covered with dense forests.
We have traded the high-altitude glaciers of the north for the dense, tropical, heavy rainfall environments of the northeast.
The jungle.
Exactly. The Purvachal Hills are defined by thick, nearly impenetrable jungle running along these parallel sandstone ridges.
So the altitude is lower, the temperature is higher, and the moisture is immense.
Creating a radically different biome, even though it's technically part of the exact same massive tectonic event that created Everest.
Wow. All right, let's take a breath and zoom out for a second.
Good idea.
We have traced the mountains from west to east and from top to bottom. But all throughout this section, we kept talking about rivers carrying sediment.
A constant theme.
The rivers grind down the rock, carry it south, and drop it. Well, over millions of years, all that dropped rock has to go somewhere.
It does.
Where does it end up? It builds the very next feature on our list. Listen to how the text introduces the northern plain.
Let's hear it.
The northern plain. The northern plain has been formed by the interplay of the three major river systems, namely the Indus, the Ganga, and the Brahmaputra, along with their tributaries.
Three massive systems.
This plain is formed of alluvial soil. The deposition of alluvium in a vast basin lying at the foothills of the Himalaya over millions of years formed this fertile plain.
Millions of years of deposition.
It spreads over an area of 7 lakh kilometers, the plain being about 2,400 kilometers long and 240 to 320 kilometers broad, is a densely populated physiographic division.
Densely populated.
With a rich soil cover combined with adequate water supply and favorable climate, it is agriculturally a productive part of India.
If the story of the Himalayas is one of violent, upward tectonic crashing, the story of the northern plain is one of slow, quiet, relentless accumulation.
It's the ultimate testament to the concept of deep time.
It really is. The text lays out the mechanics clearly. The deposition of alluvium in a vast basin over millions of years.
I mean, basin is essentially a giant depression in the earth.
Right, exactly. When the Himalayas pushed up, a massive depression formed just to the south of them.
Like a giant empty bowl.
Right. And for millions of years, the Indus, Ganga, and Brahmaputra rivers acted like an endless conveyor belt. They chipped away at the towering mountains, carried the alluvium, the nutrient-rich dirt and silt, downward, and slowly filled in that massive basin.
And the math on that filling process is staggering. It spreads over an area of 7 lakh square kilometers.
That is 700,000 square kilometers.
700,000 square kilometers of nothing but dirt washed off the mountains. It's basically the same length as the mountain range itself, 2,400 kilometers long. It is literally an ocean of soil.
And that ocean of soil leads to the most critical phrase in the paragraph. It is a densely populated physiographic division.
Right. If you want to understand the history of human civilization in this region, it all comes down to the physics of this plain.
It's the perfect recipe.
You have 700,000 square kilometers of incredibly rich soil. You have constant, reliable fresh water pouring out of the Himalayan glaciers. You have a flat landscape that is easy to traverse and build upon.
It is the absolute perfect recipe for sustained, massive-scale agriculture.
This plain is a geographic breadbasket, which is why hundreds of millions of people live upon it today.
It is the foundation of empires.
Now, the document gives us some very specific details about how these rivers behave when they hit this flat dirt. It's fascinating mechanics. Let me read this next section, which includes a few interesting side notes.
Go ahead.
The rivers coming from northern mountains are involved in depositional work. In the lower course, due to gentle slope, the velocity of the river decreases, which results in the formation of riverine islands.
Depositional work.
Doab is made up of two words, do meaning two, and ab meaning water. Similarly, Punjab is also made up of two words, punj meaning five, and ab meaning water.
Love that etymology.
The rivers in their lower course split into numerous channels due to the deposition of silt. These channels are known as distributaries.
And there's a box in the text about Manjuli, right?
Oh yes, it states, Majuli in the Brahmaputra River is the largest inhabited riverine island in the world.
Let's unpack that first phrase, depositional work.
We touched on this earlier, but it's vital to visualize the physics of a river here.
When water is rushing down a steep mountain face, gravity accelerates it,
And fast-moving water has high kinetic energy.
which means it has the power to pick up and carry heavy loads of rock, sand, and silt. It is performing erosional work, tearing the mountain apart.
But the moment that river hits the flat northern plain, it loses its steep gradient.
The gentle slope causes the water's velocity to plummet.
And just like a tired hiker who simply can't carry a heavy backpack anymore, the river drops its load of silt.
That dropping process is depositional work.
And because the river is constantly dropping silt right in its own path, it starts choking itself. That explains the distributaries.
Right. We all know what a tributary is, small streams flowing together to make a big river.
But here, the river hits its own pile of dropped dirt, and the water has to split apart to go around it, distributing itself into smaller channels.
Exactly. The river weaves and fractures across the flat plain, and occasionally it drops so much sediment in one spot that the dirt breaches the surface, splitting the river entirely around a new mass of land.
Which creates a riverine island,
Like Majuli in the Brahmaputra River.
which is so massive that an entire population lives on it. It is an island built entirely of dropped mountain dust.
That's incredible. And I also love the etymology lesson tucked into this section.
Yeah, doab, do meaning two, ab meaning water, the land sandwiched between two converging rivers.
And Punjab, Punj meaning five, Ab meaning water, the land of five rivers.
When you realize the regional names are literally just descriptions of the water geography, it clicks how deeply the physical land dictates the human identity.
Language follows the landscape. Now let's see how the text maps out the broader divisions of this massive plain.
It divides it from west to east. Listen to this.
Hmm.
The northern plain is broadly divided into three sections. The western part of the northern plain is referred to as the Punjab Plains.
The land of five waters.
Exactly. Formed by the Indus and its tributaries, the larger part of this plain lies in Pakistan. The Indus and its tributaries, the Jhelum, the Chenab, the Ravi, the Beas, and the Satluj, originate in the Himalaya. This section of the plain is dominated by the Doabs.
Okay.
The Ganga Plain extends between Ghaggar and Teesta rivers. It is spread over North India and Haryana, Delhi, UP, Bihar, partly Jharkhand and West Bengal. In the east, particularly in Assam, lies the Brahmaputra Plain.
This is a pretty straightforward wide-angle view. We have the Indus River system dominating the west, creating the Punjab Plains. We have the massive Ganga River system sweeping across the great central expanse, dominating North India.
And squeezing through the east, primarily in Assam, we have the Brahmaputra Plain.
Three vast river systems feeding three vast stretches of agricultural heartland.
But just when you think you understand the plain, the document throws a major curveball.
Oh, the relief variations.
Yeah, it's very easy to picture this 700,000 square kilometer area as a perfectly smooth, unvarying billiard table of dirt.
But the text explicitly pushes back against that assumption.
It really does. Listen to this highly detailed breakdown. The northern plains are generally described as flat land with no variations in its relief. It is not true.
Strong words for a geography text.
Right, it continues. These vast plains also have diverse relief features. According to the variations in relief features, the northern plains can be divided into four regions.
Four distinct zones.
The rivers, after descending from the mountains, deposit pebbles in a narrow belt of about 8 to 16 kilometers in width, lying parallel to the slopes of the Shiwaliks. It is known as Habar.
Habar, got it.
All the streams disappear in this Habar belt. South of this belt, the streams and rivers reemerge and create a wet, swampy, and marshy region known as Terai.
Terai is the second zone.
This is a thickly forested region full of wildlife. The forests have been cleared to create agricultural land and to settle migrants from Pakistan after partition. Locate Dudhwa National Park in this region.
Okay.
The largest part of the northern plain is formed of older alluvium. It lies above the floodplains of the rivers and presents a terrace-like feature. This part is known as Bangar.
Bangar is the third.
The soil in this region contains calcareous deposits, locally known as Kankar. The newer, younger deposits of the floodplains are called Kadar. They are renewed almost every year and so are fertile, thus ideal for intensive agriculture.
Okay, it is not true that the plains are totally flat. This is a critical breakdown.
Yeah, to understand this, I want to visualize walking directly south from the foothills of the Shiwalik Mountains, just tracking what happens to the ground under our feet.
That's the best way to do it. Let's take that walk.
What is the very first thing we encounter?
You step directly into the first zone, the Babar. The text describes it as a narrow belt, roughly 8 to 16 kilometers wide, running right alongside the base of the mountains.
Crucially, it says rivers deposit pebbles here.
Right, because pebbles are heavy. The second the river hits the flat ground and slows down, it drops the heaviest stuff first.
So we are essentially walking on a massive belt of loose rocks and pebbles.
Yes.
But the text says something almost magical here. All the streams disappear in this Habar belt. How does a river just vanish?
It's pure physics. Think about pouring a massive bucket of water onto a deep pile of loose, large gravel.
Okay, the water doesn't pool on top.
Right, it instantly sinks through the wide gaps between the stones. Because the Pabar is a thick, porous belt of loose pebbles, the water simply drops beneath the surface.
So the river is still flowing, but it's flowing entirely underground, hidden beneath the rocks.
Exactly.
Okay, so we cross the dry, rocky Habar belt, and we keep walking south. What happens to the ground next?
You enter the second zone, the Terai. At this point, the pebbles run out, and the ground transitions to finer dirt and clay.
Which is much less porous.
Exactly. So all that water that was flowing underground through the Pabar suddenly has nowhere downward to go, and it hits a wall of less permeable soil.
So it is forced to reemerge. It pops back up to the surface.
And because it's flat ground, the water just spreads out.
Which is why the text says it creates a wet, swampy, and marshy region. The Terai is a massive wetland.
Yes, and it notes this area was historically heavily forested and full of wildlife, citing Dudhwa National Park. It sounds incredibly dense and humid.
Historically, it was an incredibly difficult terrain to traverse due to the marsh and the dense vegetation. Though, as the text notes, significant portions have been cleared for human settlement and agriculture.
So we leave the swampy Terai, and we keep walking south into the main expanse of the plain. what are we walking on now?
You enter the third and largest zone, the Bangar. The key phrase here is older alluvium.
Meaning dirt that's been there a long time.
Dirt that was brought down from the mountains hundreds of thousands, perhaps millions of years ago.
Okay.
Because it is so old, the active rivers have actually carved their paths slightly deeper into the earth over time, leaving this older dirt sitting slightly higher up, away from the water.
The text describes it as presenting a terrace-like feature. It sits above the normal floodline.
And because the river isn't constantly washing over it anymore, the soil changes. The text says it contains calcareous deposits, locally known as kankar.
What exactly is Kankar?
Calcareous deposits are essentially nodules of calcium carbonate. Because the soil is older and less frequently refreshed by floods, minerals have time to precipitate and form hard, chalky clumps in the dirt.
So it is still agricultural land, but the presence of these hard nodules means it isn't the absolute most fertile soil available.
Which brings us to the final zone, the absolute prime real estate, the Kadar.
The Kadar represents the newer, younger deposits.
These are the low-lying areas immediately adjacent to the active rivers.
Right. And every single year, when the monsoon rains come and the rivers swell, they overtop their banks and flood the Kadar.
And when they flood, they lay down a micro-thin, fresh layer of extremely fine, nutrient-rich silt.
The text notes they are renewed almost every year.
This constant refreshment of minerals and nutrients makes the Kadar incredibly fertile, which is why it is deemed ideal for intensive agriculture.
Khabar, Tarai, Bangar, Kadar, pebbles, swamps, older terraces, and fresh floodplains.
We started with what sounded like a boring, flat stretch of dirt, and the text revealed a highly dynamic, structurally complex machine.
Driven entirely by the physics of water dropping sediment over time. It proves that if you know how to read the landscape, no patch of dirt is ever truly simple.
Well, we've covered the youthful active mountains and the vast sediment-filled plains. Now is time to travel south and visit the foundation.
The oldest, most resilient part of the continent.
Let's move to the Peninsular Plateau. Listen to how the document introduces this ancient rock. The Peninsular Plateau. The Peninsular Plateau is a tableland composed of the old crystalline, igneous, and metamorphic rocks.
A tableland.
It was formed due to the breaking and drifting of the Gondwana land, and thus making it a part of the oldest landmass. The plateau has broad and shallow valleys and rounded hills.
Rounded hills, unlike the jagged Himalayas.
Right. This plateau consists of two broad divisions, namely the Central Highlands and the Deccan Plateau. The part of the Peninsular Plateau lying to the north of the Narmada River, covering a major area of the Malwa Plateau, is known as the Central Highlands.
Okay, the Central Highlands.
The Vindhyan Range is bounded by the Sapura Range on the south and the Aravallis on the northwest. The further westward extension gradually merges with the sandy and rocky desert of Rajasthan.
It's painting a really wide picture here.
A flow of the rivers draining this region, namely the Chambal, the Sindh, the Betwa, and the Ken, is from southwest to northeast, thus indicating the slope.
That is a brilliant geological clue right there.
The Central Highlands are wider in the west, but narrower in the east. The eastward extensions of this plateau are locally known as the Bundelkhand and Baghelkhand. The Chotanagpur Plateau marks the further eastward extension, drained by the Damodar River.
Let's focus on the imagery of a tableland. It's a really great descriptive word.
Yeah, if the mountains are a crumpled rug, the plateau is a giant, sturdy oak table sitting in the middle of the room.
It is raised up high off the floor of the plains, but it's flat on top.
But the sheer age of this table is what's truly staggering. The text says it was formed due to the breaking and drifting of the Gondwana land.
This requires us to look back hundreds of millions of years.
To an era before the Himalayas even existed, before mammals walked the earth. This is a supercontinent era, right? Pangea?
Exactly. Earth's land masses used to be clustered together. That supercontinent eventually fractured. The southern portion of that fracture was called Gondwana.
An immense landmass.
Yeah, it contained what is now South America, Africa, Antarctica, Australia, and the Indian Plateau. Eventually, massive convective currents in the Earth's mantle caused Gondwana to tear apart.
And the Indian plate snapped off.
And began a slow, millions of years long drift across the ancient ocean.
So this entire southern half of India is essentially an ancient tectonic raft that eventually crashed into Asia.
Yes.
And because it's so ancient, it's composed of old crystalline, igneous, and metamorphic rocks. It has been baked, compressed and crystallized over deep geological time.
And its age is why it looks the way it does. The text notes it has broad and shallow valleys and rounded hills,
The sharp, violent peaks of its youth were worn down.
worn down by hundreds of millions of years of rain and wind, leaving behind a smooth, weathered, heavily stabilized landscape.
Now, the text splits this giant table into two halves, separated by the Narmada River. The top half is called the Central Highlands. And it gives us a brilliant clue about how to read the physical tilt of this table. It points out that the rivers, the Chambal, the Sindh, the Betwa, flow from southwest to northeast, thus indicating the slope.
This is a fundamental law of geography. Gravity dictates water flow.
You don't need a satellite to tell you how a continent is tilted. You just have to watch where the rivers run.
Because these rivers travel from the southwest upwards towards the northeast, eventually merging with the Ganga system, we know definitively that the table sits higher in the southwest and leans down toward the northeast.
Water acts as a natural level.
Exactly. So the Central Highlands form the top, slightly tilted half of the table.
What about the bottom half? Let's read the next paragraph. The Deccan Plateau is a triangular landmass that lies to the south of the river Narmada. The Satpura Range flanks its broad bays in the north, while the Mahadev, the Kaimur Hills, and the Mikal Range form its eastern extensions.
Triangular landmass.
Locate these hills and ranges in the physical map of India. The Deccan Plateau is higher in the west and slopes gently eastwards.
Another tilt.
An extension of the plateau is also visible in the northeast, locally known as the Meghalaya, Karbi Anglong Plateau, and North Kachar Hills. It is separated by a fault from the Chotanagpur Plateau. Three prominent hill ranges from the west to the east are the Garo, the Khasi, and the Jaintia Hills.
The visual here is a triangular landmass. If you look at the southern half of the Indian subcontinent, it naturally tapers into a giant V shape, pointing south toward the equator.
And the Deccan Plateau essentially fills in that entire V.
It does. And just like the top half of the table, this bottom triangle is also tilted. The text states it is higher in the west and slopes gently eastwards.
So the entire southern landmass is leaning toward the Bay of Bengal.
Keep that detail in mind. It is going to dictate the shape of the coastlines later on.
I definitely will. But I have to ask about a really strange geographical puzzle the text introduces here.
Oh, the Meghalaya extension?
Yes. It says an extension of this Deccan Plateau is visible way over in the northeast, the Meghalaya Plateau. It says it is separated by a fault. But if you look at a map, Meghalaya is incredibly far to the east, physically separated from the main plateau by the entire flat expanse of Bangladesh. How can it be part of the same table?
Because of a massive ancient geological fracture. Millions of years ago, the plateau was one single continuous block of ancient rocks stretching all the way to the east.
Okay.
But the Earth's crust shifted, creating a fault, a giant crack. The land between the main plateau and the Meghalaya section physically sank down, creating a massive depression.
Oh, wow.
Over time, the Ganga and Brahmaputra rivers flowed over this sunken gap, dumping millions of tons of river dirt into it, filling it up and creating the flat plains of Bengal.
Oh, so if you were to dig straight down through the dirt of Bangladesh, you would eventually hit the sunken portion of the table.
Exactly. Meghalaya is just a chunk of the original table that remained high while the middle sank and got buried in dirt.
That is an incredible piece of geographical detective work.
The deep structure of the Earth is rarely obvious from the surface. Now, let's examine the outer edges of this massive triangular table, the Ghats.
Listen to how the document contrasts them. The Western Ghats and the Eastern Ghats mark the western and the eastern edges of the Deccan Plateau, respectively.
The edges of the table.
Western Ghats lie parallel to the western coast. They are continuous and can be crossed through passes only. Locate the Thal, Bor, and Pal Ghats in the physical map of India.
Continuous.
The Western Ghats are higher than the Eastern Ghats. Their average elevation is 900–1,600 meters, as against 600 meters of the Eastern Ghats. The Eastern Ghats stretch from the Mahanadi Valley to the Nigiris in the south.
Now note the difference here.
The Eastern Ghats are discontinuous and irregular and dissected by rivers draining into the Bay of Bengal.
Discontinuous.
The Western Ghats cause orographic rain by facing the rain-bearing moist winds to rise along the western slopes of the Ghats.
Orographic rain. We'll get to that.
The Western Ghats are known by different local names. The height of the Western Ghats progressively increases from north to south. The highest peaks include the Anaimuji, 2,695 meters, and the Dodabetta, 2,637 meters. Mahendragiri, 1,501 meters, is the highest peak in the Eastern Ghats. Chevreuil Hills and the Javadi Hills are located to the southeast of the Eastern Ghats.
And it mentions the hill stations, too.
Right. Locate the famous hill stations of Udagamandlam, popularly known as Udi and the Kodaikanal. Okay, the contrast here is sharp. The edges of the table are completely different from each other.
Very different.
The Western Ghats are a towering, solid wall with an average elevation of 900 to 1,600 meters. The text says they are continuous and can only be crossed through specific mountain passes.
They form a formidable physical barrier running down the west coast.
But the Eastern Ghats, the text says they are much lower, only about 600 meters. And more importantly, it says they are discontinuous and irregular and dissected by rivers.
Wait, let me connect the dots here. If the entire plateau is tilted so that it's higher in the west and slopes to the east, that means all the water is running away from the west and crashing into the east.
You can think.
The rivers are literally slicing the eastern wall to pieces.
That is exactly the mechanism at play. Because of the tilt, powerful rivers like the Godavari, Krishna, and Kaveri originate in the west, but flow relentlessly eastward.
Just tearing through the rock.
Over millions of years, these massive rivers have acted like liquid saws, physically chewing through the Eastern Ghats to reach the ocean, rendering them discontinuous and irregular.
While the Western Ghats remain a solid wall because the water is flowing away from them, not through them.
That is a beautiful deduction based purely on gravity and water flow. Now, the text also mentions a very specific weather phenomenon regarding the Western Ghats.
It says they cause orographic rain by facing the rain-bearing moist winds to rise along the western slopes.
How exactly does a mountain cause rain?
Orographic refers to the effect of mountains on weather. The mechanism is a fascinating intersection of atmospheric pressure and temperature.
Okay.
When the monsoon season arrives, massive weather systems blow in off the Arabian Sea, heavily laden with warm ocean moisture.
And they hit the mountains.
As this wet air hits the coastline, it slams directly into the solid 1,500-meter-high wall of the Western Ghats.
And wind can't blow through solid rock, so it has to go up and over the wall.
Exactly. The air is forced violently upwards. As air rises in the atmosphere, it expands and cools. Here is the critical physics. Cold air cannot hold as much water vapor as warm air.
Ah, I see where this is going.
So as the wind is pushed up the mountain slope and rapidly cools, the water vapor reaches its dew point, condenses into heavy clouds, and unleashes massive torrential downpours on the western-facing side of the mountains.
The mountain is literally squeezing the water out of the sky like a giant sponge.
Yes, and because it squeezes so much water out on the western side, by the time the wind actually crests the peak and blows over onto the interior of the Deccan Plateau, it is relatively dry.
That creates the rain shadow.
Which is why the interior of the plateau is significantly more arid than the lush, rain-soaked western coast.
That is a phenomenal piece of mechanical geography. And the final paragraph of the plateau section gives us one last geological puzzle to solve. Listen to this.
Okay.
One of the distinct features of the peninsular plateau is the black soil area known as Disheen Trap. This is of volcanic origin, hence the rocks are igneous. Actually, these rocks have denuded over time and are responsible for the formation of black soil.
Black soil.
The Aravalli Hills lie on the western and northwestern margins of the peninsular plateau. These are highly eroded hills and are found as broken hills. They extend from Gujarat to Delhi in a southwest-northeast direction.
Okay, the text says a distinct feature of the plateau is a black soil area known as Deccan Trap. And it explicitly states this is of volcanic origin.
But wait, there are no giant active volcanoes spewing lava in the middle of India today.
Yeah.
So how did the middle of a plateau get covered in volcanic rock?
To understand this, we have to return to the story of the ancient tectonic rift.
Back to Gondwana.
Right. Millions of years ago, as the Gondwana landmass was drifting northward across the ocean, a massive section of the Indian plate passed directly over a hot spot in the Earth's mantle.
Like a supervolcano.
Well, this wasn't a conical volcano like you see in movies. It was a massive fissure, a tear in the crust that allowed unimaginable volumes of liquid basalt magma to well up and flood the surface.
A flood of lava.
Successive flows of this highly fluid lava spread out over thousands of square kilometers, cooling into dark, stair-step-like layers of igneous rock. The term trap actually comes from a Swedish word meaning stairs.
So it was a literal flood of liquid fire in deep time. But the text says these rocks have denuded over time to form black soil. What is denudation?
Denudation is the long, slow process of the Earth stripping itself bare.
Yeah.
Over tens of millions of years, the relentless cycles of solar heating, monsoon rains, and wind physically and chemically broke down that hard, dark basalt rock.
Breaking it down into soil.
Yes. The result of that breakdown is a highly unique, mineral-rich black soil. This soil is intensely good at retaining moisture and is famous for its ability to grow cotton.
So once again, an apocalyptic geological event from deep time created the precise soil conditions that drive modern agricultural economies.
Everything connects back to the rocks.
And speaking of things being worn down over deep time, the text mentions the Aravalli Hills on the northwest margin, noting they are highly eroded and broken.
The Aravallis are among the oldest fold mountains on the planet. Hundreds of millions of years ago, they may have rivaled the Himalayas in height.
But because they're so ancient,
The great equalizers of weather and gravity have had immense amounts of time to grind them down into broken, highly eroded stubs of their former glory.
and as we move past those eroded stubs of the Aravalli Hills to the northwest, we transition into an environment where weather, specifically the lack of it, has taken absolute control.
The Indian desert.
Right. Listen to how the document describes this harsh frontier. The Indian Desert. The Indian Desert lies towards the western margins of the Aravalli Hills. It is an undulating sandy plain covered with sand dunes.
Undulating plain.
This region receives very low rainfall, below 150 millimeters per year. It has arid climate with low vegetation cover. Streams appear during the rainy season. Soon after, they disappear into the sand as they do not have enough water to reach the sea.
Disappearing streams again.
Luni is the only large river in this region. Barchans, crescent-shaped dunes, cover larger areas, but longitudinal dunes become more prominent near the Indo-Pakistan boundary. If you visit Jaisalmer, you may go to see a group of barchans.
The physical description here is an undulating sandy plain. Undulating means rolling, like slow waves on the ocean. But here, the waves are made of sand.
And the primary driver of this landscape is an extreme atmospheric deficit. The text states it receives below 150 millimeters per year of rainfall.
To put that in perspective, areas of the Western Ghats we just discussed might receive 2,000 or 3,000 millimeters of rain, squeezed out by orographic lift.
The desert receives almost nothing. It is a harsh, arid extreme.
And because of that extreme lack of water, we see a phenomenon that sounds a bit like the Babar Belt, but the mechanics are entirely different.
Right, the text says, streams appear during the rainy season. Soon after, they disappear into the sand as they do not have enough water to reach the sea.
In the Babar, rivers disappear because they sank into deep, highly porous gravel beds. In the desert, streams disappear because they are defeated by the atmosphere.
The heat just bakes them.
The intense heat of the arid climate causes rapid, aggressive evaporation. What little water doesn't evaporate is quickly absorbed by the dry sand.
The streams simply do not have the volume, the sustained flow, or the kinetic energy to fight their way across the landscape to the ocean. They just perish in the sand.
The Luni is noted as the only river with enough volume to sustain itself for any significant distance.
The text also gives us a very specific visual marker of this wind-sculpted environment. Barchans. It defines them as crescent-shaped sand dunes.
If you close your eyes and picture the classic, sweeping, curved ridges of sand in a deep desert, those are barchans.
The text suggests visiting Jaisalmer to see them.
Because there is virtually no water to bind the soil together and no thick vegetation roots to anchor the ground, the earth is entirely at the mercy of the wind.
The wind becomes the master architect.
Exactly, endlessly shifting, glowing, and carving the undulating plains into those massive sweeping crescents.
From the absolute driest place on the map, we are now going to travel to the very edges of the continent, where the land finally meets the ocean.
The coastal plains.
Let's listen to how the text describes the margins of the plateau. The coastal plains. The peninsular plateau is flanked by a stretch of narrow coastal strips, running along the Arabian Sea on the west and the Bay of Bengal on the east.
Flanked by strips.
The western coast, sandwiched between the Western Ghats and the Arabian Sea, is a narrow plain. It consists of 3 sections. The northern part of the coast is called the Konkan, Mumbai, Goa. The central stretch is called the Kanad Plain, while the southern stretch is referred to as the Malabar Coast.
That's the west side.
Now, the east side. The plains along the Bay of Bengal are wide and level. In the northern part, it is referred to as the Northern Sircar, while the southern part is known as the Coromandel Coast.
Wide and level.
Large rivers, such as the Mahani, the Godavari, the Krishna, and the Kaveri, have formed extensive delta on this coast. Lake Chilika is an important feature along the eastern coast.
And there's a box about Lake Chilika too, right?
Yeah, it notes the Chilika Lake is the largest saltwater lake in India. It lies in the state of Odisha. to the south of the Mahanadi Delta.
So we have the massive raised table of the plateau in the center, and these coastal plains are like the thin strips of bread flanking the sides of a very thick sandwich.
But the document highlights a major asymmetry between the two pieces of bread.
Yes.
The west coast is sandwiched and narrow, but the east coast plains are wide and level. Why aren't the coastal margins uniform all the way around?
This is where all the geological mechanics we've discussed so far perfectly converge.
Oh, this connects to the tilt?
Think back to the tilt of the Deccan Plateau. The land sits higher in the west and leans gently eastward.
Right.
Because of that tilt, we established that all the massive rivers flow eastward, violently slicing through the eastern Ghats. Well, those rivers are carrying billions of tons of eroded sediment from the plateau.
Oh.
When they finally break through the eastern mountains and hit the flat ocean boundary, they lose their velocity. And just like the rivers forming the northern plain, they drop their massive loads of silt.
So over millions of years, the rivers have dumped so much sediment on the eastern edge that they've literally built new land outward into the ocean.
That's what the text means when it says they have formed extensive delta on this coast.
A delta is a massive fan of sediment deposited at a river's mouth.
Because multiple massive rivers are constantly dumping dirt there, the eastern coastal plain has been pushed outward, becoming exceptionally wide, flat, and level.
While the west coast is a completely different story.
The steep, unbroken wall of the Western Ghats drops almost directly down into the Arabian Sea. Because the water flows away to the east, there are no massive rivers dumping sediment to build the land outward.
Thus, the western plain remains tightly sandwiched and narrow.
It's all connected. The tilt of the table determines the flow of the rivers, which determines the width of the coastlines.
And the text notes the regional names for these coastal strips: Konkan, Kanad, and Malabar in the west, Northern Sircar and Coromandel in the east.
It also specifically highlights Lake Chilika, identifying it as the largest saltwater lake in India, situated right near that massive Mahanadi Delta buildup.
Formed largely by the complex interplay of ocean currents and massive river sediment deposition creating coastal barriers. We have now mapped the entirety of the mainland. But the document insists we have one final isolated frontier to cover. Let's look at the islands.
The last geographic puzzle piece.
I'll read the first part of this section, which includes a fascinating sidebar on marine biology. The islands. You've already seen that India has a vast mainland. Besides this, the country has two groups of islands. Can you identify these island groups?
Directing the reader again.
Locate the Lakshadweep Islands group lying close to the Malabar coast of Kerala. This group of islands is composed of small coral islands. Earlier, they were known as Lakshadweep, Minicoy, and Amindive. In 1973, these were named as Lakshadweep.
Okay.
It covers a small area of 32 square kilometers. Kavaratti Island is the administrative headquarters of Lakshadweep. This island group has great diversity of flora and fauna. The Piti Island, which is uninhabited, has a bird sanctuary.
And then the box about corals.
Right. Corals. Coral polyps are short-lived microscopic organisms which live in colonies. They flourish in shallow, mud-free, and warm waters. They secrete calcium carbonate.
Microscopic organisms.
The coral secretion and their skeletons from coral deposits in the form of reefs. There are mainly of three kinds: barrier reef, fringing reef, and atolls. The Great Barrier Reef of Australia is a good example of the first kind of coral reefs. Atolls are circular or horseshoe-shaped coral reefs.
The text states plainly that the Lakshadweep Islands are entirely composed of small coral islands.
We've talked about tectonic plates crashing, lava flooding, and rivers dumping dirt. But how does a living biological organism build a physical island capable of supporting human habitation?
It is arguably the most astonishing mechanism of land creation on Earth. The text explains the biology. Coral polyps are short-lived microscopic organisms. They secrete calcium carbonate.
What exactly is a coral polyp?
A coral polyp is a tiny, soft-bodied creature, somewhat like a miniature sea anemone. To protect its soft body, it extracts calcium from the warm seawater and secretes a hard, rocky skeleton made of calcium carbonate, which is essentially limestone.
A tiny creature building a rock shell. But an island requires millions of tons of rock.
Which is why the text specifies they live in colonies.
Yeah.
Billions upon billions of these tiny creatures clustered together.
Just piling on top of each other.
Exactly. When one generation dies, the next generation builds its limestone skeleton directly on top of the old ones. Over tens of thousands of years, this microscopic architectural project builds massive underwater mountains of limestone.
As long as the water is shallow, mud-free, and warm, they will keep building until the reef breaks the surface of the ocean.
So the Loshadweep Islands are quite literally towering mountains built entirely out of billions of microscopic skeletons.
That is beautiful and sort of eerie. The text mentions three specific forms: barrier reefs, fringing reefs, and atolls.
An atoll is particularly fascinating.
Hope so.
Imagine an ancient volcanic island sinks slowly beneath the waves due to tectonic shifting. The coral living in the shallow water around the edges of the volcano keeps growing upward, trying to stay near the sunlight, even as the center of the volcano vanishes into the deep. Eventually, you are left with a ring, a circular or horseshoe-shaped reef surrounding a central lagoon of water where the volcano used to be. The Lakshadweep chain is famous for these incredibly beautiful atoll formations.
It's wild to think about geology being driven by biology. Now let's contrast that with the second island group. Listen to how the document describes the Andamans.
Okay.
Now you see the elongated chain of islands located in the Bay of Bengal, extending from north to south. These are Andaman and Nicobar Islands. They are bigger in size and are more numerous and scattered.
Bigger in size.
The entire group of islands is divided into two broad categories: the Andaman in the north and the Nicobar in the south. It is believed that these islands are an elevated portion of submarine mountains.
Submarine mountain.
These island groups are of great strategic importance for the country. There is great diversity of flora and fauna in this group of islands, too. These islands lie close to equator and experience equatorial climate and has thick forest cover.
And there's one more box at the end.
Yes, it notes, India's only active volcano is found on Barren Island in Andaman and Nicobar group of islands.
So we have a massive contrast. Lakshadweep was tiny, a total area of just 32 square kilometers, built by tiny coral creatures.
And the Andaman and Nicobar Islands are bigger in size, and the text notes they are believed to be an elevated portion of submarine mountains.
This takes us right back to tectonic forces. If you were capable of draining all the water out of the Bay of Bengal, you would see that the Andaman and Nicobar Islands are not just rocks floating in the sea.
There are mountains.
They are the absolute highest, sharpest peaks of a colossal mountain range entirely submerged underwater. This submarine mountain range is actually a southern continuation of the tectonic folding forces that created the Purvachals in the northeast.
So it's a massive underwater crumble zone. And the islands are just the very tips of the mountains that manage to push high enough to break through the surface of the ocean.
Exactly. And because this is an active tectonic boundary where massive plates are still grinding against each other, the Earth here is highly volatile.
That is why the text explicitly notes, India's only active volcano is found on Barren Island.
The crust is thin and fractured enough here for deep magma to reach the surface.
The document also highlights the specific climate of these islands. Because they sit so far south, they experience equatorial climate and has thick forest cover,
They are drenched in immense heat and heavy equatorial rains.
creating staggeringly dense, isolated jungles packed with diverse flora and fauna. It's a completely different biome from the rest of the country.
And geopolitically, their location is paramount. Sitting far out in the Bay of Bengal, they straddle some of the most critical, heavily trafficked maritime trade routes connecting the Indian Ocean to the Pacific.
Giving them the great strategic importance the text mentions.
We have done it. We have painstakingly decoded this massive physical map.
We have, translating the text to understand the youthful mountains, the deep alluvial plains, the ancient central plateau, the shifting desert, the sediment-built coasts, and the biological and tectonic islands.
We've explored the sheer mechanics of the landscape.
And that brings us to the final paragraph of the document. This is where the authors pull all these disparate threads together to deliver a final thesis. Let's read the conclusion.
Read it out.
A detailed account of the different physiographic units highlights the unique features of each region. It would, however, be clear that each region complements the other and makes the country richer in its natural resources.
Complements each other.
The mountains are the major sources of water and forest wealth. The northern plains are the granaries of the country. They provide the base for early civilizations.
Granaries.
The plateau is a storehouse of minerals, which has played a crucial role in the industrialization of the country. The coastal region and island groups provide sites for fishing and port activities. Thus, the diverse physical features of the land have immense future possibilities of development.
This is the ultimate synthesis. This entire deep dive hasn't just been about rocks and dirt. It has been about understanding how geography dictates human destiny.
The text gives each distinct region a specific vital job within the broader ecosystem of the nation.
Let's lay those jobs out. The Himalayas are the water tower.
Without those massive, youthful peaks forcing the monsoon winds upward and trapping ice in glaciers, there are no great rivers flowing south to sustain life.
The northern plains are the breadbasket. The text calls them the greeneries.
Without the millions of years of river dirt dumped into that flat basin, creating perfectly level, hyperfertile soil, there is no agricultural base to support a billion people.
It is the literal foundation of the early civilizations.
The Peninsular Plateau is the toolbox. It is the storehouse of minerals.
Because it is an ancient, stable, heat-baked, volcanic origin landmass, it is heavily concentrated with iron, coal, and the precious metals necessary to drive modern industrialization.
And the coasts and islands are the doorways. They provide the ports, the fishing grounds, and the physical connection to the rest of the global economy.
When the text says each region complements the other, it's pointing out a profound interdependence.
You cannot have the fertile plains without the young mountains acting as a massive geological grinder to create the dirt.
You cannot have the wide eastern coasts without the tilted central plateau forcing the rivers to carry sediment to the ocean.
The entire landmass is an incredibly intricate machine, powered by deep tectonic forces and the relentless slow movement of water.
It is a machine of immense scale and balance developed over billions of years.
Which brings us to a final thought I want to leave you with. We have spent this entire deep dive looking backward, analyzing how millions of years of continental drift, volcanic flooding, and glacial grinding have shaped the map of India into the fixed, permanent-looking document we opened the show with.
We draw our maps in dark ink and assume the mountains will always be exactly where they are.
But the grand illusion of geography is permanence. The truth, based on everything we've read today, is that the machine is still running.
It hasn't stopped.
The Indian tectonic plate is still relentlessly pushing north into Asia at a rate of a few centimeters every single year.
The Himalayas are technically still growing taller.
The rivers are actively tearing them down and dumping new Kedar soil on the plains. The earth is shifting, rising, and eroding right beneath our feet. It is just happening far too slowly for our short human lives to register.
So true.
So if the staggering diversity of this landscape, the towering peaks, the flat plains, the volcanic plateaus, was all sculpted by these violent, slow forces over millions of years past, what will the physical features of this landmass look like millions of years from now?
What completely new, unimaginable map will future civilizations have to draw?
It is a staggering prospect to mull over. Thank you for taking this incredibly detailed journey with us and for walking through this document step by step to uncover the deep, mechanical stories written into the very stone and soil of the earth. We'll catch you on the next deep dive.